Jupiter dominates our solar system. It's 140,000 kilometres across and 2.5 times more massive than the rest of the planets put together. On this scale, if Jupiter were the size it appears on the screen, about 2.5 metres across, then the Earth would appear the size of this basketball, and it would fit into Jupiter about 1,000 times over. We think that Jupiter was the first planet to be formed. It sort of hoovered up most of the stuff left behind after the Sun's formation. And like the Sun, it's mainly made up of hydrogen and helium, about 95%. The other 5% is made up of heavier elements. And it's all spinning incredibly fast. This vast planet rotates on its axis once every 10 hours. As it spins, the clouds of its atmosphere are driven into thick bands by the powerful winds that orbit the planet. Those swirling forces create giant storms, like the famous red spot. Even though we've been studying the planet for over 400 years, there's still much that is quite mysterious about Jupiter. One of the first things Juno is aiming to discover is what powers those giant storm systems. To find out how it's going to do that, I went to talk to Jupiter expert and Juno collaborator Lee Fletcher. So Lee, what are we seeing here?
This is actually a beautiful movie that was taken by the Cassini spacecraft when it flew by Jupiter back in the year 2000, 16 years ago. So you can see in this image just how dynamic the Jovian atmosphere is. Things are changing all of the time as we have these jets of wind whizzing east and west and separating the beautiful banded structure. And we think that these bright white clouds at the equator are regions where air is welling up from the deeper interior and it's dredging with it particles or molecules of ammonia gas. And those ammonia gas molecules condense and it forms ice crystals. And those ice crystals create these white colours within the equatorial zone.
Okay, that's the white bands, but how about these darker bands?
Now that's an even harder question to answer, unfortunately. But of course, what comes up must then ultimately go down. And what we believe is happening is the air that's rising over the equator is then sinking over the northern equatorial belt and the southern equatorial belt. Those ice crystals evaporate away and they reveal the natural colours of Jupiter deeper down within the planet. Unfortunately, we still don't know what is actually causing the brown colour. What you can see here as well is that the belts look much more active and much more dynamic than the white regions. And we think that all of that activity is being driven by the same molecule that drives atmospheric weather here on planet Earth, and that's water vapour. You're familiar with if you have a humid atmosphere, it's more prone to thunderstorms, tropical storms,
hurricanes and things.
Yes. Well, the same phenomena could be occurring within Jupiter. But if water is part of the story for what's driving this incredibly dynamic atmosphere, then we'd have to understand where the water is located within Jupiter and how much, crucially, how much is there within the planet.
So how can we do that? Can we go any deeper?
So Juno's got a very clever instrument called a microwave radiometer on board. And what we can see in microwave light is modulated by the amount of ammonia that's there and the amount of water that is there. So by building up this map, and it will take a while to build it up, many months of the Juno mission going over various longitudes to paint a complete picture of the planet, we'll then be able to map where the water is located and where the ammonia is located.
So that might give you an understanding of what's driving those weather systems.
Absolutely. Juno is going to be a step change in our understanding of how much water is present within the Jovian atmosphere.